Jai Hind students, in this particular session we will discuss some numericals which are based on the equations of motion. Students, in the previous lecture we have mathematically verified the equations of motion. There are three equations of motion. The first one is, you must be aware, it is V is equal to U plus AT. That's the first equation of motion, and it is known as velocity-time relationship. It is the time and velocity which are variable. U and A are constants. These equations are basically valid for uniformly oscillated motion when the oscillation of the body is constant, right? So it is velocity-time relationship. What's the second equation of motion? It is also known as displacement-time relationship, and the relationship is S, which is the displacement, it's equal to ut plus half AT square. S and T, these are the variables, U and A being constant. It is known as displacement time relationship, right? Third equation of motion. It is 2AS is equal to V square minus U square. Here V and S, final velocity, and S displacement are variable. So it is known as displacement velocity relationship. So these three are collectively known as equations of motion. And I repeat, these equations are valid only when A is constant. Right, students? So, all the questions written over here, they are based on equations of motion. So, we just need to choose the appropriate equation to be used in that particular numerical. Right? So, let's start with the first one. Let's start with the first one. Okay. First question is, a bus decreases its speed from 72 km per hour to 54 km per hour in 5 seconds. Calculate its acceleration. Look, decreases its speed from 72 to 54 km per hour. So what's the initial speed? Initially, so it is represented by U. It is given to be 72 km per hour. And after 5 seconds, what is the final speed of the bus? It is given to be 54 km per hour. You need to write this, the given information. U stands for the initial velocity, V stands for the final velocity. And the body is decreasing in speed from 72 to 54 in time 5 seconds. Now we need to find out acceleration, like this, to be found. Right? So, we need to make use of the proper formula. So, first and foremost, what we need to do is, in SI, which is System International D Units or Standard International, the SI unit of acceleration is meter per second square. So, what to do is, we need to convert all the physical quantities in the same system. Right? We need to express velocity in meter per second. So, first and foremost, before solving it, you need to know the conversion. 1 km per hour is equal to, let's convert it in meter per second. 1 km is 1000 meters, we all are aware. 1 hour is 60 minutes and 1 minute is 60 seconds. So it is 1000 divided by 3600. So it will be equal to 5 by 18 meter per second. Students, please do remember this. 1 km per hour is equal to 5 by 18 meter per second. So whenever the speed is given in kilometer per hour, don't forget to convert it in meter per second. This should be the first step. Now, what is the relationship between V, U, T and A? We can make use of the first equation. So, from first equation, we get V equals to U plus AT. So, AT would be equal to V minus U, or A would be equal to V minus U by T. You can directly like this. You can directly write this. Acceleration is given by the time rate change in the velocity, right? So let's substitute the value. What is the final velocity? 54. So it will be 54 into 5 by 18. So let's convert it in SI. So what you get is 18,354, so it will be 15 meter per second, right? So V is 15 meter per second. Minus, what is U? 72 km per hour. Let's convert it in meter per second. 1 km per hour is 5 by 18 meter per second. So 72 km per hour would be 72 multiplied by 5 by 18. So it will be 72. So 4 into 5, that is 20 meter per second. So it is 20 meter per second. Divided by time. The time derivative, the speed changes from 72 km per hour to 54 km per hour. The time is going to be 5 seconds. So what do you get? Minus 5 divided by 5. So it is equal to minus 1. What would be the unit? Meter per second square. Right? So what is the acceleration? What is the answer? Minus 1 meter per second square. This negative sign suggests that it is the case of retardation. Look students, it's a simple concept. Whenever the final speed of the body is less than that of its initial speed, then A will always come out to be negative. So it will be the case of retardation. So express your answer either like this, A equals to minus 1 meter per second, or write retardation is equal to 1 meter per second square. While writing retardation, you need not to write negative sign over here. Right? So this is the solution of the first question. I hope you have understood it. So the first step is to convert kilometer per hour into meter per second. And do remember this concept. 1 kilometer per hour is 5 by 18 meter per second. Right? So let's discuss the second question. Just concentrate on the second question, students. Second question is, a car starting from rest moves with constant acceleration of 0.1 meter per second square for 2 minutes. Find speed acquired and also the distance traveled. Right? So let's start with the second question. Let's extract the given information from the question. What it's written is a car starting from rest. Starting from rest means what is the initial speed of the body? It is 0. It is given. Moves with the constant acceleration of 0.1. So acceleration is given to be 0.1 meter per second square. First write down all the values which are given in the question. For 2 minutes. Time is given to be 2 minutes. Don't forget to convert it in seconds. In SI, the unit of time is seconds. So 2 into 60, it will be equal to 120 seconds. Right? Find speed acquired and distance traveled. So V is to be found and displacement is to be found. So whenever you start a numerical, first write in this particular manner. All the given information write in this manner, and these are the quantities which needs to be found. Right? So U is given, A is given, T is given, we need to find out B. So students, we can make use of first equation of motion. Just remember those 3 equations, right? One of those equations will be used in a numerical. So from first equation we get V is equal to U plus AT. This is from first equation of motion. This is from first equation of motion, the velocity-time relationship. V is to be obtained. What is U? 0. What is A? 0.1. And what is time? It is 120. So V would be equal to, this decimal 0 get cancelled, so we will be left with 12. So what is the velocity acquired by the car after 2 minutes? It will be 12 meter per second. Very simple, students. Very simple. Okay, next one is distance covered. Here you have 2 options. You can either make use of second equation of motion, or you can also make use of the third equation of motion. Right? It's entirely up to you. So you can make use of second equation of motion. It is S equals to ut plus half at square. So S is the displacement, U is 0. So it will become 0. 0 multiplied by anything would be 0. Half, acceleration is 0.1. And T square is 1/22 square of this. So let's solve it. So it will be half multiplied by 1 by 10 multiplied by 12 square, it's 144 multiplied by 100. Right? So what do you get? 0, 0 get cancelled. 2, 72. So S would be equal to 720 meters. Is it clear, students? You can also solve it by using third equation of motion as well. You can check it. From third equation of motion we get 2as is equal to v square minus u square. Right? So 2a is given, it's 0.1. S is to be found. What is v? V is obtained to be 12. So square of this minus u is 0. So let's solve it. So 2 into 0.1 into S is equal to 144. So S would be equal to 144 divided by 2 into 0.1. That is 72 by 0.1. It would be equal to 720 meters. So students, it's entirely up to you to make use of either of these two equations. Either by using second equation of motion or by using third equation of motion, you can easily get the result. So it's entirely up to you, right? So this is how the distance covered as well as the final velocity of the car can be obtained, right? Okay students, third one, it's quite interesting one. Let's read the question, the third one. A stone is thrown in a vertically upward direction with velocity of 5 meters per second. If A is 10 meters per second square in the downward direction, what will be the height attained by the stone and how much time will it take to reach there? Right? So here I must mention you a very important fact. Now whenever we throw a stone or a ball in the vertically upward direction, then what happens is, as the ball tends to gain height, its speed keeps on decreasing, and eventually and ultimately when the ball or the body reaches the highest point, then it momentarily stops. That is, its velocity at the highest point becomes 0. So this is a very crucial point. So suppose this is the surface of the earth, a ball is thrown. So it will be thrown with the initial velocity. So as it gains height, its speed will keep on decreasing. The length of the arrow suggests that the speed of the ball keeps on decreasing. And eventually and ultimately, it will reach the highest point where the final velocity of the body would be 0. Here, the final velocity of the body would be 0. And thereafter, in case air friction is neglected, it will retrace its path and will again come back following the same path in case air resistance is neglected, right? So anyway, what I mean to say is that in the case of a ball which is thrown in the vertically upward direction, the final velocity at the highest point is 0, right? This is the initial velocity and this is the final velocity. Clear, students? So this is the question based on this fact only. A stone is thrown in a vertically upward direction with velocity of 5 meters per second. So u is given to be 5 meters per second. This is the initial velocity, and as it increases its altitude, its speed keeps on decreasing, and eventually at the highest point its final velocity becomes 0. Right? At the highest point, the body stops momentarily. That is, its final velocity becomes 0. Right? Acceleration is in the downward direction. This is the direction of the acceleration in the downward direction. It's given to be 10 meters per second square. Now students, look, while using the formula, you need to check whether A is to be assigned positive sign or is to be assigned negative sign. In the case of retardation, A is negative. In the case of acceleration, A is positive. Now think over here. V is greater than U or V is less than U? V, which is the final velocity, is less than the initial velocity. So it means that with the increase in the time, the speed of the body keeps on decreasing and eventually the body comes at rest. So it must be the case of retardation. And in the case of retardation, A is to be taken as negative. So minus 10 meters per second square. This is very important. Also, you can understand this by using this fact as well. This is the direction of motion of the body and this is the direction of the acceleration. So obviously both being opposite, acceleration should be assigned negative sign. So it must be the case of retardation. So A, it should be given to be negative of this, right? So U is given, V is given, A is given. We are supposed to find out the height attained, means S is to be calculated. In place of S, you can write it as h. So as I have stated, make use of either second equation of motion. Second equation, I think time is not given, so it is not applicable. So here we will make use of third equation of motion. So third equation of motion is 2as is equal to v square minus u square. Let's solve it. 2 acceleration, it is minus 10. Students, please note it down. A is to be substituted as minus 10. S, which is the height, it is the distance covered by the body. What is the final velocity at the highest point? It is 0. What is the initial velocity with which the stone was thrown? It is 5. So let's solve it. Minus 20h is equal to minus square of 5, it's 25. So h would be equal to minus get cancelled. 25 by 20. So it is equal to 5 by 4, that is 1.25 meter. This is the height which this stone will attain, right? Let's discuss the second part. How much time will it take to reach there? This is the initial time. So what is the time in which the stone will reach the highest point? So for that, what do you use? We can make use of this first equation of motion, v is equal to u plus at. This is the first part and this is for the second part. What is the final velocity over here? 0. What is the initial velocity? 5. What is acceleration? It is minus 10. And time taken by the stone to reach from the bottom to the highest point is considered to be small t, right? So let's solve it. So it will be 10t is equal to 5, which implies that t is equal to 5 by 10 is equal to half or 0.5 seconds. So students, again, simply by making use of equations of motion, these questions can be easily solved, right? So the height attained is 1.25 meter, while the time taken by the stone to reach the highest point is 0.5 seconds, right? Okay, let's proceed further. Let's discuss the fourth question. Students, fourth question. Again, it's a different scenario. In the third question, we have discussed the vertically upward motion. In the fourth question, it is dropped. A body is dropped. So whenever a body is dropped, it is not given in some initial velocity. It is simply dropped. So when a body is made to fall freely, then the initial velocity of the body is to be taken as 0. That's the key point, right? So fourth question is, a body is gently dropped. Fourth question. A body is gently dropped from a height of 20 meter. This is the height. It's given to be 20 meter, and a ball or a body is simply dropped. It's dropped like this. It's not imparted any initial velocity. It's simply dropped. Drop means it is released. So initial velocity is 0. Remember, initial velocity is 0. In the case of a vertically upward motion, the final velocity of the body at the highest point is 0, right? And in this case, during the release of a body from a height, its initial velocity is 0. So, at the rate of, its velocity is increasing at a uniform rate of 10 meter per second square. Remember, it's not velocity which is given. Meter per second square is the unit of acceleration. So velocity is increasing at a constant rate of 10 meter per second square. So it is the acceleration which is given. 10 meter per second square. Now when a body is dropped, what happens is its velocity will keep on increasing. Earlier it is 0. Now as it falls, its velocity will keep on increasing. And at the instant when it strikes the ground, its velocity is maximum. So here the final velocity would be much more as compared to the initial velocity. Therefore, v is greater than u. It must be the case of acceleration. The body is speeding up. Its speed increases. So, A is positive over here, right? So, what we are supposed to find is, if its velocity increases at the uniform rate of 10 meter per second square, which is the acceleration given, with what velocity will it strike? Also, calculate the time taken by the body to reach the ground, right? So, these are the things given. So what to do? We can make use of S is also given 20 meter. So we can make use of, I think, the second equation of motion so as to get the value of time. So let's find T first. From second equation of motion, we know that S equals to ut plus half at square. Students, just practice as much numericals as you can. So in that manner, automatically you will get to know which equation of motion is to be used for that particular numerical, right? Just you need to practice. There is no golden rule. Just golden rule is practice more and more numericals. It will automatically come to your mind which of the three equations are to be used. So here S is given, it's 20. Initial velocity is given to be 0. 0 multiplied by anything would be 0. Half. Acceleration is plus 10. T is to be found. Right? So we can easily get 20 is equal to 5t square. Or t square is equal to 20 by 5, that is 4. Or t equals to 2 seconds. Plus minus 2. So time can't be negative, so avoid that negative sign. So we'll get t equals to 2 seconds. So this is the time which it will take to reach the ground. Right? Okay. Let's consider the second part. Second part is, we are supposed to find out the final velocity. So we can make use of the first equation of motion. Initial velocity is 0, acceleration is 10, and time we have already calculated is 2. So with what velocity the body will strike the ground? It is 20 meter per second. The ball will strike the ground with a final velocity of 20 meter per second. Right, students? Again, simply make use of appropriate equation of motion. Okay, let's consider the fifth question. A car is moving with velocity of 72 km per hour. Its velocity is reduced to 36 km per hour after covering a distance of 200 meters. Calculate retardation in centimeter per second square. We are supposed to find out the retardation in centimeter per second square. So, let's write down the given values. Moving with velocity of u is given to be 72 km per hour. Students, don't forget to convert it in meter per second. So it will be 72 multiplied by 5 by 18. So 18 4 to 5 4 are 20 meter per second. This is the initial velocity. Then its velocity is reduced to itna. So this is the final velocity, which is 36 km per hour. So 36 into 5 by 18. So it will be 10 meter per second. Right? This is the first step to convert in SI. And after covering a distance of, what is the distance covered during this? It is given to be 200 meter. We are supposed to find out acceleration. So students, which relation would you use? What is the equation connecting all these four, u, v, s and a? Yes, it's the third equation of motion. So third equation of motion is 2as is equal to v square minus u square. Here we will make use of this equation, right? Let's substitute the value and we will get the result. Twice a, what is s? 200. What is v? 10. What is u? It's 20. So let's solve it. So it will be 400a is equal to 100 minus 400. So 400a is equal to minus 300. So a would be equal to minus 3 by 4. It will be in meter per second square. Isn't it, students? But the question is, we need to find out the retardation in centimeter per second square. So what we can do is, it is equal to minus 3 by 4. 1 meter is 100 centimeter. So it will be centimeter per second square. So it comes out to be minus 75 centimeter per second square. This is the acceleration. Now you are supposed to find out retardation. So if you write it retardation over here, then you need not to assign this negative sign. So it is 75 centimeter per second square. So this is the answer, students. Right? This is how the retardation can be found. So the numerical is important from the point of view of conversion of the units. Here you need to convert kilometer per hour in meter per second. And again in the last step you need to express the acceleration in centimeter per second square. Okay? Well, the last question, sixth one. Let's try that one. A body is moving, sixth question, students, please concentrate. A body is moving with constant acceleration of, sixth question, acceleration is given to be 10 meter per second square, right? If the body starts from rest, so students, when a body starts from rest, it means that its initial velocity is 0. It is starting from rest. Earlier it is at rest, then it is converting its state from rest to motion. So in that case, if a body is starting from rest, initial velocity is always 0. Then calculate its displacement after 5 seconds. So students, which equation would you prefer? Connecting S, U, T and A. Obviously, the second equation of motion. Second equation of motion is S equals to ut plus half a t square, right? So S would be equal to, what is U? 0. 0 multiplied by anything would be 0 only, half. What is acceleration? Is given to be 10. And what is the time? It's going to be 5. So what you get is 5 multiplied by 5 square. So it is 5 multiplied by 25. So it is 125 meters. Right? So this will be the displacement covered by the body during 5 seconds. So students, I hope I am able to, or I am rather able to convince you how to proceed like with numericals. And here I must state that numericals are core, they are the integral part of physics. Without numericals, physics is incomplete. So first, have a sound theoretical base, theoretical knowledge, and then attempt the numericals. And do attempt numericals as many as possible. Try to solve as many questions as possible. And once you get confident, once you acquire that confidence, you'll yourself feel happy while doing and solving and getting correct answer of such numericals, right? So with that, all the very, very best, and do study well. We'll continue in the next session then. Take care.